Glenn.
It is, and its development's not quite out there yet. It's still coming. This is a small drone. This is a Mavic type drone. Now imagine this and other drones that would go to a specific predetermined place around a bridge after an earthquake and being able to measure that bridge to determine whether it can be opened as quickly as possible to get us back to normal. For 2 years, King 5's been following the construction of an experimental bridge that's part of the new SR-99 tunnel project. It forms a ramp handling traffic heading into downtown Seattle and uses new technology, flexible concrete, and nickel and titanium alloy pins that allow the bridge to snap back into its original position. The bottom line is this: in the wake of an earthquake, it could be inspected quickly and start carrying traffic. But what about the thousands of other bridges in Washington? Inspections involve people, some in bucket trucks, looking for bending and cracking that could make a bridge unusable even if it doesn't collapse. We may need to wait weeks to drive over a bridge that's structurally okay, but still awaits inspection.
The goal here is to avoid disasters that follow disasters.
Tashkin Badir is an associate professor of electrical and computer engineering at Northeastern University in Boston. First responders that can't get to where they're needed, trucks that can't move, people who can't go back to work, delays in helping the economy begin to recover, all creating that follow-on disaster even long after the shaking has stopped. And he's leading development of another type of technology and its ability to inspect bridges faster: drones.
If you have one operator who goes down to a bridge and then flies 10 drones or multiple of those systems at the same time, you can get the job done very quickly.
Badir is working with the Center for Regional Disaster Resilience here in the Northwest to develop that technology.
To the right? Okay. Yep.
Visual inspections using drones are happening now. Puget Sound Energy has begun to inspect power lines. Burlington Northern Santa Fe Railway inspects bridges, track, and roadbeds, often at hard-to-reach areas. The Northeastern Drone Development Program would have multiple drones running almost autonomously. It would not only have cameras, but an additional technology called LiDAR. We've shown it to you here before. Think of it like light radar. It creates these incredible images that help geologists understand landscapes and faults by stripping away trees. Each picture made from millions of individual LiDAR pulses, each a measurement, a collection of computerized data that can identify problems.
This is definitely an emerging field. On a daily basis, a better sensor comes up. I think any form of sensing is game to identify the anomalies at the end of the day. We are looking for something that doesn't look right.
So again, it's not ready yet, but the use of drone technology is progressing quickly, even here in the news business, where we have our own drones and more on the way.
Okay, so how exactly do these drones know that there has been a change or damage?
That's the thing. So you go out and they would go out and fly it before, and they would basically map all the bridges in town.
Like a baseline
picture. So, okay, this is what normal looks like. And then afterward, and this is where the automation comes through and everything else, that drone would go back to that predetermined spot determined by altitude and location by the global positioning system and say, oh, well, when we sent the beam down here before, it was this far. Now it's that far plus 5 inches, which means something's sunk or something's disappeared or something's cracked. And as you heard him talk, it was about they're looking at maybe other technologies. And part of it is how much weight it can carry, how much you want to pack onto this. But the idea is you sort of have a swarm of these things under control of an operator, but a lot of it would be autonomous. And again, there's still a lot of ways to go.
Certainly a lot.